Hello, everybody. Welcome back to the clarification and answer series. So remember the previous video we have compute the necessary substitution term, right? So we find on the partial u with respect to x, partial square of u with partial respect to x, and remember the general goal is for us to find s and eliminate necessary t term. Okay, so after all this, us go ahead and substitute in. So from 4 right here, I show you guys 4 3 2, we can substitute it back to 1, which is our original equation. Okay, so let me write down. So let's go ahead and write plug 2 3 4 into 1. Okay, so what do we have? Okay, so we substituted in and we should get partial g over partial t times s plus partial s over partial t times g plus partial g over partial x times c times s plus partial s over partial x times c times g, okay, equal to what? Equal to beta times partial square of g with respect to x, second partial derivative, all right, times s plus mu times 2 times partial g with respect to x times partial s with respect to x plus mu times partial square of s with respect to x, okay, which is the second derivatives, at here times g. Okay, now let's go ahead and clean up this mess. Okay, so to clean up this mess, first of all, I would try to make this term appear, or partial t, with respect to partial t. In order for that to happen, I'm gonna divide by s, by both sides. So let me write divide s both side. Okay, divide s both side. What do we get? We get partial t with respect to t. Okay, plus partial s with respect to t times g over s plus partial g with respect to x times c plus partial s with respect to x times g over s equal to mu times partial square over g with respect to x, second derivative, plus mu times 2 over s times partial g with respect to x plus partial s with respect to x plus mu times g over s times partial square of s with respect to x, second partial derivative. All right, so what do we have here and what's our goal? Okay, first of all, I want y'all to take a deep breath. It's gonna be okay. There's a lot of terms right now, but we can simplify it. So our goal is to arrive this equation, right? So we want this first. We want the time to remain partial g with respect to t, and we want this term to remain too. We want the, oh my bad, just make sure I don't destroy the s right there. Okay, so we want 3 of these green terms to remain, right, to look like a separable partial differential equation. That's what we want. We want the rest to disappear, okay, but it have to disappear in a correct order. You can't just set each of these terms equal to 0. Let's see how we make it disappear. Okay, so let me write down. So we want to square to remain. Oh my god, wrong color, to remain. The rest to disappear. Okay, all right. How do they disappear? Let us rearrange in terms of coefficient. So what do I mean by coefficients? So remember how I say like these terms have to disappear in order. So what you're gonna do is there's certain coefficient. In this case, it is g and partial g with respect to x. We want all any term that contain those two coefficients to go, or in mathematical term equal to 0. Okay, so I will do some arrangement and you see it immediately. So if I do some rearrangement, I'll get partial g with respect to t plus g, okay, times partial s with respect to t times s plus partial s times c over partial x times s plus mu over s times partial square of s with respect to x square, okay, plus partial g with respect to x of c minus mu times 2 over s times partial of s with respect to x. All this equal mu times partial square of g with respect to x. Okay, so what is the next step? So we want the coefficient to disappear, right? So what does it mean? It means that these, we want g and partial g with respect to x to go, right? And because we just want the times and the second derivative with space to remain, like I mentioned previously. So for the two yellow term to disappear, it has to times a 0. So what does it mean is all this right here, the green, this thing and this thing have to become 0. Y'all say what I'm saying? Because no matter what is g and no matter what is partial g with respect to x, if it times 0, it will be gone. Okay, and s we can choose. That's why s, remember, s is something we choose. It's a supplementary function. It's something we can pick. So let me write that. In order for g and partial g with respect to x to disappear, okay, so so these must equal 0. Okay, so I mean the green circle. So so what do we have? So we will say partial of s with respect to t times 1 over s plus partial of s with respect to x times c over s minus mu over s times partial s squared over x squared equals 0. Okay, I will call this equation 5. And then the next thing we have is c minus mu times 2 over s times partial s over partial x equals 0. And this is equation 6. Okay, so we have these two constraints, right? 5 and 6. We can use these two constraints, 5 and 6, to find s, right? Okay, so how do we do that? Okay. It's good you have a proposal, but how do we do that? First of all, if you look at 5 and 6, you pick an easier equation to start with. In this case, the easier equation is the one that probably, if my first impression, just like, you know, Facebook post, what is your first impression of me? If my FI of this system equation is which one is shorter, that one is simpler. So I'll pick 6 to start with. So let's go ahead and say 6. And remember, I'm going to find s, okay? So 6, if I put rearrange, I will write c equal mu times 2 over s times partial s over partial x. Okay, I will isolate the partial term on one side. So partial s over partial x equal to c times s over 2 times mu. Okay, so I will make it like, I will use the method of separation of variables, s on one side and the rest on another side. So I write partial s with respect to s equal partial x times c 2 mu. S on one side, s on one side, the rest on the other side. Separation of variable. Okay, it seems like our time's ticking off. So I'll stop the video here, and next video we'll continue this saga for y'all.